We are now on part 2 of chapter 8, and in this section we are going to discuss security policies. Page 359 discusses security policies and GPO, group policy objects. Manual computer configuration means you have to walk up to each individual computer to configure it. So if you wanted to install Microsoft Word and disable the use of USB drives on every computer in the organization, you would have to go up to the first computer and install Microsoft Word and disable the USB drive. Then you'll have to go to the second computer and install Microsoft Word and disable the USB drive, and go to the second computer, third computer, and the fourth computer. CCBC has 5,000 computers. To manually walk around to each individual computer would be incredibly labor-intensive and time-consuming. This is why we have GPO, Group Policy Objects. A Group Policy Object is a configuration file which is located on the domain controller, but it applies to all users and computers in the domain. That way we can centrally configure all computers in the domain without having to walk up to those computers. Let's look at two examples of group policy. One would be the remote installation of software, and the other would be disabling the use of the USB drive. So instead of walking around to each computer and installing the software, we go to the group policy object on the domain controller. If we go to the domain controller to the group policy objects, we can go into software settings and we can install the software on the domain controller so the software is pushed down to the workstations. And we can go into device installation restrictions and select prevent its installation of removable drives, and you will see that this configuration parameter disables the use of USB drives. And of course, the reason we might want to do that if we were in a highly secure environment. With group policy objects, you don't walk around to each individual server, to each individual workstation. You configure the group policy object on the server, and what that does is it configures every workstation in the domain. If you either want to remotely install software to push it down from the domain controller, or if you want to configure that computer's security parameters. Group policy allows us to centrally configure our many workstations. That's central configuration. Now, let's turn to page 360 and discuss what's meant by centralized storage. Where can data be stored? It can be stored locally on the hard drive, centrally on a file server, on a storage area network, or on a cloud server. So let's look at each one of those four. Now, a user can save files locally to his own individual hard disk. But if he then goes to another computer and tries to retrieve the file, the user says, hey, where are my files? So what we do is we tell the user to save the files centrally up to the file server. And that way, if a user goes to another computer, then the user can still have access to the files regardless of where that user is located. A home directory is a folder on the file server under the user's folder where a user can save all of his confidential files. When Bob logs on, he saves files up to the Bob folder on the server. And when Mary logs on, she saves files up to the Mary folder on the server. This is called a home directory. If you go into user properties for the user Bob and look at the profile, his user profile and his home folder indicate that his home folder is located up on the server in the user's folder, in a folder which has the same name as his username, which is Bob. A home folder is a folder on the server where that user and only that user has access to files. You put stuff that only you are going to access in your home folder. And then we have shared public folders, and that's when we want to have multiple people work on the same project at the same time. We might have a shared projects folder, and that way multiple people can collaborate on a single project. Multiple people can access the same files at the same time. So a file server is a central storage location. And there are really two types of shared folders: a home folder, which only one person can access, or a public folder, which many people can access. Now let's go to page 361 and discuss what's meant by a SAN, a storage area network. Now, in a local area network, typically the disks are in the servers, and that makes for inflexible storage allocation because the disks are in the servers. In a typical network, the disks are in the servers. So if each server only needs two hard disks, that's great. But suppose this server needs 3 hard disks worth of capacity. Well, I guess I could turn 2 of the servers off, pull one of the hard disks out of this server, and move it up into the other server, but that's kind of a lot of trouble. And suppose this server only needs a half a hard disk worth of capacity. Well, I really can't very easily take out a saw and cut that hard disk in half. So as it is, each server has 2 disks of storage capacity, whether it's enough or whether it's not enough. And this is called the traditional storage with disks in the servers. With a storage area network, you get an external disk array. And the disks are not in the servers, but the disks are all stored in the disk array. And this is called a storage area network, where the servers connect to the disk array. Now, let's not confuse it with a local area network. Users stand at workstations on the local area network that connect to the switch, that connect to the servers. But the disk array is part of the storage area network, and that's all stored in the server room. With a storage area network, we could allocate 3 disks to the first server, we could allocate 1 disk to the second server, and we could allocate, if we needed to, just a half a disk to the second server. With a storage area network, the disks are not in the servers. We have a single external disk array, which is also called arrayed array, and then the servers connect to the disk array, and disk space is allocated to servers as necessary, and the point is it's a much more efficient utilization of resources. Page 361 discusses cloud-based storage. A cloud server is just a server that can be accessed from the internet. And you know what the cloud is. The cloud is the internet. So a cloud-based server is a server which can be accessed from the internet. So if you're at Starbucks working on your laptop computer, you can save data up to the cloud server. And then you could go to work to your desktop computer at work, and you could still access those same files on the cloud server. What makes it a cloud server is simply the fact that it can be accessed from the internet. So you could be at Starbucks, you could be at home, you could be at work, you could save all your files up to the cloud server. Cloud server is useful when we have collaboration between people who are in different locations. If we have somebody in San Francisco, somebody in Boston, somebody in Miami, all working on the same project, they can all work on the same files located centrally on a cloud server. So data can be stored locally on the local hard disk of the user's workstation. It can be stored centrally on a file server. Data can be stored on a storage area network, or data can be stored centrally on a cloud server. Now let's turn to page 361 and discuss infrastructure servers. 3 types of infrastructure servers include domain controller, DHCP server, and DNS server. Well, you already know what a domain controller is. It's just another word for a login server. And you also know that a DHCP server is a server which issues IP addresses to workstations so you don't have to walk around and manually issue the IP addresses. Now let's discuss what's meant by a DNS server. A DNS server performs host name resolution. So can you please turn to page 362 and let's look at what's meant by a DNS server. DNS is a hierarchical method of organizing computers. The DNS domain space starts with a root and it's subdivided into top-level domains such as .com, .net, .gov, .org, and .edu. And those top-level domains such as .com are divided into second-level domains such as Cisco or Microsoft or Walmart. And the .edu top-level domain can be subdivided into Harvard, Princeton, and the Community College of Baltimore County. In DNS, a host name is just another word for the name of a computer. You could name a computer Server 1, or another example of a host name would be Database Server. You might call your mail server simply Mail, and web servers are usually named www. They don't have to be, but they usually are. This is called a host name. A fully qualified domain name is where you take the host name and then you add onto it the secondary level domain, and then you add on to that the top level domain. And a URL, also known as a Uniform Resource Locator, is where you add the protocols such as HTTP in front of the fully qualified domain name. And I think everybody knows what an IP address. It is a number which is written in dotted decimal notation. So let's look at DNS host name resolution. Very important thing in DNS, host name resolution. We will discuss the following things: a DNS client, which is also called a resolver, web server, host name, packet, IP address, and a DNS server. So let's start out with the user who wants to access the web page on ccbc.edu. The web page for CCBC is located on server 10.0.0.5. So if a user at a workstation wanted to access the web page, and if he knew the IP address, the user could just type http://10.0.0.5 and press the enter key. And then TCP/IP would send a packet to the web server, and the web server would send the home web page back. IP would send a packet to 10.0.0.5 because that's the IP address of the web server. Now here's the question. How does IP know to send a packet to 10.0.0.5? Well, that's kind of obvious. That's what the user typed in. If the user typed 10.0.0.5, well then of course IP is going to send the packet to 10.0.0.5. But users usually cannot remember IP addresses. They usually remember host names, such as ccbc.edu. Typically, a user would type www.ccbc.edu to access the web page. So if the user types ccbc.edu and presses the enter key, then the IP protocol will send a packet to the IP address for ccbc.edu, and that's 10.0.0.5. Now, here's the question. How does the IP protocol know that when the user types www.ccbc.edu, how does it know to send the packet to 10.0.0.5? And the answer is it asks the DNS server. A DNS server is a server which has a number of host records. A host record is a computer name and an IP address. So the DNS server has the names of all the web servers at CCBC and their corresponding IP addresses. So when the user types www.ccbc.edu and presses the enter key, well, the user doesn't know it, but the IP protocol sends a signal to the DHCP server to find out what's the IP address for what the user just typed, ccbc.edu. The workstation sends a query to the DNS server to find the IP address of ccbc.edu. The DNS server sends the IP address back to the workstation, and now the IP protocol knows that the IP address of ccbc.edu is 10.0.0.5. The IP protocol then sends the packet to 10.0.0.5, which of course is the IP address of our web server. And this whole process is called host name resolution. In other words, the user types ccbc.edu, but the packet header has to have the IP address of the destination computer. In host name resolution, the user at the client types in the name of the web server, typically based upon host name. The workstation then sends a signal, a query to the DNS server, which has host records on it. It finds the IP address that corresponds for the host name that the user just typed, which is the IP address of the DNS server, sends that IP address back to the IP protocol, and then the IP protocol sends the packet to the web server. This is called host name resolution. Now let's look at configuring the client, configuring the DNS client to point to the DNS server. We want to make it so whenever the user types a host name, that the workstation sends a query to the DNS server, which in this case is 10.0.0.150. So to configure the DNS client so it will push all user queries to the DNS server, what you do is you go to TCP/IP protocols. Now you already know what the IP address, subnet mask, and default gateway is. A fourth variable that we type in when we configure TCP/IP is the IP address of the DNS server, which in this example is 10.0.0.5. The reason we type in the IP address of the DNS server is so when the user types a host name, then the workstation knows to push the query up to the DNS server, which in this case is 10.0.0.150. Now suppose we had made a typographical error and had accidentally typed 151 in the client's configuration. Well, if we did that, then the client would not send its queries to the DNS server. It would send it to whatever computer has 151 as an IP address. So when you configure the IP address of the DNS server on the workstation, make sure you get the IP address correct. So the main point in DNS is this. The main point is that the client asks the DNS server the IP address of the web server. Why? Because users cannot remember IP addresses, but they can typically remember host names. Page 364 discusses fault tolerance, and fault tolerance is based upon redundancy. It means if one component fails, that's okay, we have another one. And here's an example of fault tolerance in DNS Server Replication. As you know, a DNS server could crash at any time. So not only do we have a primary DNS server, but we typically have a secondary DNS server, which is identical to the primary DNS server. And every 15 minutes, the primary DNS server replicates all of its host records to the secondary DNS server. So if the primary DNS server crashes, that's okay. The secondary DNS server is right there. This is an example of fault tolerance. Server clustering, page 365, is another example of fault tolerance, specifically what is called failover clustering. In failover clustering, you have two servers. The first one is operational and the second one doesn't do anything. The first server responds to all client requests, and only when the first server fails does the second server kick in. How does the first server know, or how does the second server know that the first server failed? Well, these two servers are connected with a cable, and periodically the first server sends a signal to the second server, and that is called a heartbeat. And if the second server ceases to receive the heartbeat from the first server, well, that means the first server has crashed, so then the second server takes the place of the first server and starts responding to client requests. Failover cluster. Now, RAID, which stands for Redundant Array of Integrated Disk Drives, is another form of fault tolerance. It's also called disk mirroring, but we will cover RAID in Chapter 9. And this covers the end of Part